Over the past several weeks, people all over the planet have been noticing something strange. Radios have gone silent in the middle of the day for no obvious reason. GPS signals have jumped and stuttered on phones and in cars. Airline pilots have had to reroute flights away from the poles. And in places that almost never see anything like it, people have looked up at night and watched the sky ripple. With color, glowing curtains of green and red stretching across the horizon in locations that have no business seeing an aurora at all. Individually, each of these events might look like nothing more than an odd news story, a strange little glitch in the background hum of modern life. But when you start lining them up, side by side, when you look at how many of them are happening at once, in the same stretch of days, across completely unrelated parts of the world, a very different picture starts to form. This isn't random. It's happening right now, and it is absolutely not a coincidence. To understand what's actually going on, you have to go back to the one thing every single one of these events has in common, and it isn't buried underground or hiding in some secret government facility. It's 93 million miles away, and it's the reason life on Earth exists at all. It's the sun. And right now, the sun is doing something it does roughly once every 11 years. Only this time, it's doing it with more force than almost anyone predicted. The sun doesn't behave the same way every single day. It moves through a long, rolling cycle of activity, roughly 11 years from start to finish, swinging between quiet stretches called solar minimum and much more violent stretches called solar maximum. During solar minimum, the sun's surface is relatively calm. Sunspots are rare. Flares are rare. Weeks can go by without anything dramatic happening at all. But during solar maximum, the sun's internal magnetic field becomes twisted and tangled, distorted by the fact that its equator spins slightly faster than its poles. That twisting builds up enormous amounts of magnetic tension beneath the surface, and eventually that tension has to release. When it does, it erupts outward in the form of sunspots, solar flares, and massive eruptions of charged particles called coronal mass ejections, blasted out into space in every direction, including, quite often, straight at us. We are currently living through solar cycle 25, the 25th such cycle astronomers have tracked since they started numbering them back in the 1700s. For years, forecasters expected this particular cycle to be a weak one, similar to the relatively quiet cycle that came before it. That prediction turned out to be wrong. Solar cycle 25 has consistently outperformed its own forecasts, producing more sunspots, more flares, and more geomagnetic disturbances than the models originally called for. Scientists now believe the actual peak of this cycle likely happened sometime between late 2024 and the middle of this year. But here's the part that catches a lot of people off guard. The sun doesn't just switch off the moment it passes its peak. In fact, some of the most violent solar storms in recorded history have happened not at the exact peak of a cycle, but in the years just after it, during what's called the declining phase. Two of the largest flares ever recorded during the previous solar cycle happened more than 3 years after that cycle's official peak. So even as solar cycle 25 begins its slow decline, there is no guarantee at all that the fireworks are anywhere close to finished. And this year has proven that in dramatic fashion. In the first week of February alone, the sun produced 6 separate X-class solar flares, the strongest category of flare that exists, all within just 4 days of each other. X-class flares are not subtle events. They release as much energy in a matter of minutes as billions of hydrogen bombs, and when they're aimed at Earth, they can hit our planet's upper atmosphere with a wave of radiation that arrives at the speed of light, just 8 minutes after leaving the sun. The burst of radiation slams into the ionosphere, the electrically charged layer of our atmosphere that radio signals bounce off of to travel long distances, and it can disturb that layer so severely that high-frequency radio communication simply stops working, sometimes for hours at a time, across entire E regions of the planet facing the sun. That's exactly what happened during that stretch in February. Radio blackouts were reported around the globe, sudden and widespread, tracing directly back to a single, massive sunspot region that had grown so magnetically complex it was practically begging to erupt. The particular sunspot behind that chaos was so large and so tangled that scientists gave it its own designation, and it kept firing off flare after flare for days. One of those eruptions, an X8.3 class flare, was powerful enough that space weather forecasters started referring to it as a monster. And when a flare that size sends a coronal mass ejection barreling toward Earth, the effects don't stop at radio blackouts. Those charged particles eventually slam into our planet's magnetic field, triggering what scientists call a geomagnetic storm. That's the exact mechanism behind the aurora, the northern and southern lights. Normally, auroras stay fairly close to the poles, visible mainly in places like northern Canada, Scandinavia, Iceland, or the far southern reaches near Antarctica. But when a geomagnetic storm is powerful enough, it can push that glowing curtain of light much further from the poles than usual, into places that almost never get to see it. During that same chaotic stretch in February, a diffuse aurora was spotted over southern Brazil, an almost unheard of sighting made possible by a naturally weak point in Earth's magnetic field known as the South Atlantic Anomaly. People who had never seen the aurora in their lives, who lived thousands of miles from where it normally appears, suddenly found it glowing faintly in their own night sky. This is the pattern worth paying close attention to, because it's the key to understanding why none of this is a coincidence. A single sunspot region on the sun's surface can, within the span of a few days, cause a radio blackout over one continent, a GPS error over another, and an aurora glowing in a place that has essentially never seen one before. These aren't three unrelated news stories. They are three different symptoms of the exact same root cause, arriving on Earth at nearly the same time because they were all triggered by the exact same eruption, 93 million miles away. When you see stories about strange radio interference, unusual satellite behavior, and rare auroras all clustering together in the same week, that clustering isn't random noise. It's the fingerprint of a single, specific event on the surface of our own star. And the stakes involved go well beyond a pretty light show or a temporarily fuzzy radio signal. Modern civilization has become extraordinarily dependent on technology that space weather can directly disrupt. GPS satellites, the same ones your phone uses to give you directions, rely on extremely precise timing signals that can be thrown off by disturbances in the ionosphere, sometimes shifting positioning data by dozens of feet or more during a strong storm. Airlines that fly polar routes, some of the busiest and most fuel-efficient long-haul routes in the world, have had to reroute flights away from the poles during major solar storms, both because radiation exposure increases at high altitude, thus near the poles during these events, and because communication with those aircraft can become unreliable exactly when it's needed most. Power grids are vulnerable too. A strong enough geomagnetic storm can induce unexpected electrical currents in long transmission lines, currents that were never part of the system's original design, and in extreme cases, that kind of surge has been enough to damage transformers and knock out electricity for entire regions. Then there's the newer piece of this puzzle that didn't even exist a couple of decades ago, the sheer number of satellites now orbiting the Earth. Companies have launched thousands of small satellites into low orbit to provide global internet service. And those satellites sit in exactly the part of the atmosphere that expands and becomes more turbulent during a geomagnetic storm, which increases atmospheric drag and can pull satellites out of their intended orbits faster than expected. One space weather forecaster summed up where we currently stand about as clearly as it can be put. As she described it, the real question today isn't whether a solar storm is going to happen. It's whether we're actually prepared for the disruptions these storms are capable of causing. It's worth pausing here to understand just how far our modern experience of a solar storm is from what people would have experienced a century and a half ago. In 1859, a solar eruption now known as the Carrington event sent a geomagnetic storm crashing into Earth so powerful that telegraph H systems across Europe and North America failed. Some operators reported sparks jumping from their equipment, and auroras were reported as far from the poles as Cuba and Hawaii, glowing bright enough in places that people reportedly woke up in the middle of the night thinking the sun had already risen. Back then, the only real piece of vulnerable technology on the entire planet was the telegraph network, and even that was enough to cause chaos. Today, we have satellite constellations, GPS networks, high-frequency radio communication, and power grids that span entire continents, all of it interconnected, all of it running constantly, and all of it sitting directly in the path of the same kind of event that knocked out telegraph wires more than 160 years ago. Scientists have long warned that a storm on the same scale as the Carrington event, if it happened today, wouldn't just cause sparking wires. It could take down satellites, disable large sections of the power grid for weeks, and cost economies around the world an enormous amount in EOS, damage, and lost productivity. That's part of why agencies like NASA and NOAA keep a constant, unblinking watch on the sun, using spacecraft specifically positioned to give us as much advance warning as physics allows. That monitoring effort is more sophisticated than most people realize. NASA's Solar Dynamics Observatory stares directly at the sun around the clock, capturing detailed images of its surface and tracking sunspot regions as they grow, twist, and eventually erupt. Further out, spacecraft positioned between the sun and Earth act almost like an early warning buoy, sitting in a stable gravitational point roughly 1 million miles from our planet, watching for coronal mass ejections as they leave the sun and estimating how fast they're moving and whether they're aimed at Earth at all. Because those materials travel at speeds that can range anywhere from a few hundred to a few thousand miles per second, the warning window these instruments provide is often measured in hours rather than days. That's enough time for power companies to take precautionary steps, for satellite operators to adjust orientations or shut down non-essential systems temporarily, and for airlines to reroute flights. but it's a far cry from the kind of long-range forecasting we take for granted with ordinary weather here on the ground. So if you've noticed a run of strange stories lately, unexplained radio silence, satellites behaving oddly, auroras showing up somewhere they've never been seen before, all clustered together in the same short window of time, you're not imagining a pattern that isn't there. The pattern is real, and it has a name. It's solar cycle 25. Still more active than anyone predicted years ago it would be, still capable of firing off massive eruptions even as it moves into its declining phase, and still very much connected to what's happening on Earth, in ways most people never stop to think about in their daily lives. What makes this moment particularly worth watching is that we are, historically speaking, right in the window where the biggest surprises tend to happen. Looking back at the previous solar cycle, the two largest flares on record from that entire 11-year stretch didn't occur anywhere near the official peak. They happened years later, well into the decline, almost as if the sun saved its most dramatic outbursts for a moment when most people had already stopped paying attention. If solar cycle 25 follows anything like that same pattern, then the events we've already seen this year, the radio blackouts, the auroras reaching Brazil, the GPS disruptions, might not be the final chapter of this story. They could just be an early preview of what's still coming. There's a temptation, whenever a cluster of strange events happens at once, to reach for the most dramatic possible explanation. Online, it doesn't take long for scattered stories like these to get stitched together into something far stranger than what's actually going on, framed as signs of forces nobody wants to talk about openly. It's an understandable impulse. People are pattern, seeking by nature, and when several unusual things happen in the same short window, the brain wants to find the thread connecting them. In this case, there genuinely is a thread connecting them. It's just not a hidden one. It's been sitting in plain view, studied by astronomers for centuries, publishing its own activity reports in the form of visible sunspots that anyone with the right equipment can observe for themselves. The real story isn't that something is being concealed. It's that most people simply aren't used to thinking about the sun as an active, occasionally violent participant in daily life on Earth, rather than a fixed, unchanging backdrop that just happens to keep us warm. The real explanation is sitting in plain sight, burning quietly in the sky above us every single day, doing exactly what stars like it have done for billions of years and will keep doing for billions more. What's different right now is simply the intensity of this particular stretch of the cycle and how deeply our modern world, with its satellites, its power grids, and its global positioning systems, has woven itself into a level of technological dependence that leaves us more exposed to the sun's moods than at any other point in human history. The events piling up around the world right now aren't scattered coincidences waiting for someone to connect. TT the dots. The dots are already connected. They always were. They just all lead back to the same place, 93 million miles away, where a restless, churning ball of plasma is once again reminding us, in the most literal sense possible, that we live under its influence far more than most of us ever stop to consider. Scientists tracking the sun right now don't have a crystal ball. Space weather forecasting has come a long way, but predicting exactly when the next major eruption will fire and exactly where on Earth its effects will land hardest is still an inexact science, closer in some ways to hurricane forecasting than to something like predicting a solar eclipse, which can be calculated years or even centuries in advance with total precision. Flares and coronal mass ejections, by contrast, can build for days and then erupt within minutes, sending forecasters scrambling to issue warnings with only hours of lead time before the effects reach Earth. That uncertainty is part of why events like this keep catching so many people off guard, and part of why, when several strange things start happening around the world in the very same week, it can feel like something mysterious is unfolding rather than what it actually is. A very old, very natural process playing out on a star we've been living beside for the entire history of our species. The next time you see a headline about a sudden radio blackout, a satellite behaving strangely, or an aurora lighting up the sky that almost never sees one, it's worth remembering what's really behind it. It isn't a coincidence, and it isn't a mystery in any DP sense either. It's the sun doing what it periodically does, reminding an entire planet, all at once, just how connected we all still are to the star that made us possible in the first place. And that, in the end, is what makes this story worth telling in the first place. Not because there's a secret hiding behind it, but because the truth is stranger and more humbling than any invented explanation could be. Every radio that goes quiet, every satellite that drifts slightly off course, every glow of green, light in a sky that has never shown it before, all of it is a direct physical message traveling across 93 million miles of empty space, arriving on our doorstep within minutes or hours of leaving its source. We are not separate from the sun's activity, watching it from some safe distance. We are sitting inside its outer atmosphere, bathed constantly in its light and its radiation, protected by a magnetic field that mostly does its job, but occasionally lets a surge of that activity through. What's happening right now, across radios and satellites and night skies around the world, is simply what it looks like when a star like ours flexes its muscles, and a civilization built on invisible signals and precise timing gets to feel, however briefly, just how much it still depends on something it can never fully control.